Good afternoon, class. We are looking at uh, section 5.4 of the OpenStax. Right triangle trigonometry. Here's part 2. Example 8, navigation and surveying. A bearing is used to represent the direction of one point relative to another point. Method 1. The direction or bearing of a point is the number of degrees in the angle measured in a clockwise direction. Clockwise. From the north, which is considered the vertical line, right? To the line joining the center of the compass with the point. So in this case, the center would be the point we are referring to. And we're going to look at various points like P1 and so forth. So let's look at P1, for example. So basically, we start with north and we go counterclockwise. So I want to make sure we understand. We have to go this way, everybody. Okay. So the first one, when we go this way, is what? For P1, what is the angle that we move on? 30 degrees. P2, when we move this way, this is 180 plus 50. So we go this much, and then we add this much. 180 plus 50. 180 plus 50. 230 degrees. Now P3, we go this much, and then we need to add this much. Now, when you move here, it's 270 degrees. How much more? If this is 70, everybody, this must be 20 degrees. So we have 270 plus 20, 290 degrees. P4, this is the angle. So basically, if we go all the way to here, would be 180 degrees. Subtract 20. So again, how do we arrive at this? 180 minus 20. One more time. Why is that? Here's the angle. Since this is 20 degrees and this all the way to here would be 180. 180 minus 20, that means 160 degrees. So that's how you find the bearing. If you just mention an angle, that means with respect to north only. However, the second method says direction or bearing of a point O to point P equals the acute angle theta between ray OP and the vertical line O north-south. In other words, the closest angle to north or the south. That's what we figure. So for example, P1, obviously north, because it's closer to north, 30 degrees. Now to the right is east or west, it's east. P2. P2, it's closer to the south than the north. So the first we mentioned south. What is the difference here? The angle reads 50 degrees. So south 50 degrees. If it's on the left, west. If it's on the right, east. It's on the left, therefore west. South 50 degrees west. P3, closer to north than south. So north, we write it first. The angle is 70 degrees. Again, to the left would be west. Finally, P4, closer to the south or north, is closer to the south. So first we say south, then we say the angle 20 degrees. To the right is east, south 20 degrees east. So a quick recap. You either just look at the north only, so for P1, for example, would be 30 degrees. For P4 would be this much, which is 180 minus 20. Or the second method, you start either with north or south. For example, for P1, north is closest. So north, 30 degrees, to the right is east. But this one, north, 70 degrees, and it's west. We're talking about P sub 3. So that's how you do the bearing. Those are all the answers that are written here. An airplane takes off from a runway which has a bearing of north, 20 degrees east. It flies for 1 mile. So let's stop right then and there. So north, south, east, west. So it's going to go north, 20 degrees east. So in this direction, okay? North, 20 degrees east for how much? 1 mile. And then the pilot requests permission from the control tower and turns 90 degrees heading towards northwest. So 90 degrees, you make a 90-degree angle here, but going towards northwest, this way. And it goes for 2 miles. So it goes this way, and it goes for 2 miles. What bearing should the control tower use to locate the aircraft? So that means we're going to connect those. So we want OQ. And the bearing from O to Q is north. Okay. This angle, west. What is this angle? We're going to call it alpha. So bearing of O to Q is north, alpha, west. So all we have to do, figure out what's alpha. And what is alpha? If we figure out this angle, which is theta, this entire angle is theta. We subtract 20, we get to alpha. Alpha is theta minus 20 degrees. So all we have to do in this right triangle, find this angle, and tan of this angle is the opposite PQ over the adjacent OP, which is 2 over 1, which is 2. So if tan theta is 2 and it's not a common arc, theta must be tan inverse of 2. You put it into a calculator, 63.4 degrees. Alpha is theta minus 20. So subtract 20. 43.4 degrees. So we're going to write north, 43.4 degrees, west. A quick recap. It's going to go north 20 degrees east, then it's going to make a 90-degree angle towards the west. Over here covers 1 mile, over here covers 2 miles. So 1 and 2, we can calculate the entire angle here called theta, subtract 20 degrees from it, gives you alpha, and therefore the direction. A security camera is mounted on a wall 9 feet above the floor. What angle of depression should be used if the camera is to be directed to a spot 6 feet above the floor and 12 feet from the wall? I hope you realize we have to have a setting to make some sense out of this. In other words, this is 9 feet, the camera is somewhere here, and so this is 9 feet. This is somewhere here where the camera is. And this distance is 12 feet. This angle, we're going to call it A. This is 6 feet above the floor. Okay, so this is 9 feet above the floor. And it's going to, camera is angled such that it can see this spot. What is this spot? To be directed to a spot 6 feet above the floor. And 12 feet from the wall. So that should be pretty straightforward, everybody. Now, tan of alpha is the opposite over adjacent. So what is the opposite? If the total is 9 and this is 6, this must be what? 9 minus 6. 9 minus 6 is 3. Now you have the opposite to be 3, adjacent to be 12. We can find tan of A. Which makes it 1/4. And therefore A is tan inverse of 1/4. And you put it into a calculator. Tan inverse of 1/4 is given, and it's almost 14 degrees. It depends on how many decimals they ask you. Always go with as many decimals as possible and then follow the instruction. A straight trail with an inclination of 17 degrees leads a cottage at an elevation of 9,000 feet. So we have an elevation of 9,000 feet. To a mountain peak at an elevation of 11,200 feet. Find the length of the trail. In other words, here's the trail. This is a 17-degree angle. It's 9,000 feet elevation. So the cottage is here somewhere. And the peak at A such that the distance AB is 11,200. So let's call this something C. So we want this distance of AC. This is the question asking us. This is what the question is asking us. So the setup will help. So if AB is 11,200, then what is AC? It's the difference between the two. Which is 2,200 feet. Now the length of the trail is X. So we are looking to find X. Since we have AC, we can say sine of 17 is the opposite AC over the hypotenuse X. The opposite AC is 2,200. The hypotenuse X is missing. So sine of 17, the opposite AC, 2,200 feet over X. And so X becomes 2200 over sine of 17. You put it into a calculator, gives you the answer with a couple of decimals. 7,524.67, same unit, feet. Find the inclination or grade of the trail. In other words, we want this angle B, and we can see that if you look at this triangle, the opposite is 3,100 feet, and the hypotenuse is 14,100. So it's easy to use sine of B, which is 3,100 over 14,100. And it simplifies, you drop the two zeros. And so B is sine inverse of this number. Putting it into a calculator and using, for example, one decimal, B is 12.7 degrees. Again, you always want to pay attention to what they ask you for the number of decimals. A visitor at the top of the Gateway Arc, which has a height of 630 feet in St. Louis, Missouri, observes a boat moored on the Illinois side of the Mississippi River 2,070 feet directly across from the arc. So that is a distance of 2,070 feet. She also observes a boat moored on the Missouri side directly across from the first boat. Okay, so there are two boats, one on this side, one on the opposite side. Given that B, angle B, is cotangent inverse of 67 over 55, that means you can put it into a calculator to find the angle. So this is given. Estimate, and they say estimate maybe 1 or 2 decimals. Estimate the width of the Mississippi River at the St. Louis riverfront. So what do we need to do here? We need to understand what's going on here. This distance is given. So if I can find this distance, subtract it from 2070. So if this is X, which we are looking for. Subtract it from 2070, we are done. So one more time. This distance is given. If we can find this X, subtract it from 2070. So how do we find that? Let's figure it out. So this is angle of A plus B. This is angle A, this is angle B. And if we want to find the tangent is the opposite, which is this much, 2070, over the adjacent, which is this much, 630. And so A plus B would be tan inverse of this number. Of course, you can drop the common 0, but just I want you to see exactly where the numbers are coming from. So if A plus B is that, what is A? I need the angle A to get to X. Angle A must be this minus B. And B is cotangent inverse of 67 over 55. Again, I'm still carrying this 0 on purpose, class, okay? Because I want you to see where the numbers are coming from. Now you put this into a calculator, gives you an answer. You put this into a calculator, gives you an answer. This one, you use the tan inverse. This one, you can write the reciprocal and use the tan inverse. Because it's positive, you can do that. So tan inverse of this number, 207 over 63, is this number. Tan inverse of, notice cotangent inverse, because of the limitation of a calculator, you may not have cotangent inverse. So you use tan inverse and you write, instead of 67 over 55, notice we have 55 over 67. And the difference between the two is 33.69 degrees, the difference between the two. So now, if A is given as 33.69 of almost 34 degrees, and we know it's the opposite, x over the adjacent, the height of 630, then x is the product of these two by the cross product. Putting it into a calculator results in 420 feet. So we found the x, subtracted from 2070, and you get 1,650 feet. Now, the reason I went with the whole number, everybody, because they are asking for the estimate. Because they are asking for the estimation, I figure that's fine, because everything they have used is an estimation. However, as far as the exam is concerned, just see how many decimals they're asking. So a quick recap. We have this total distance of 2070. We have this height, so we can find the angle, which we call it A plus B, through tangent inverse. When we find that, subtract the B from it, and we get the angle A. Now that we have angle A, x over 630 would be tan of that. We can find x, subtract it from 2070. There you have it. The Gibbs Hill Lighthouse, Southampton, Bermuda, is operating since 1846. Stands 170 feet, 117 feet high on a hill, 245 feet high. So it's on a hill that is 117 feet, and itself is 245. That's why the total of, if you add them up, you get, so its beam of light is 362 feet above the sea level. A brochure states that the light itself can be seen on the horizon about 26 miles distant. Verify the accuracy of this statement. Earth radius is about 4,000 miles. We're going to go with 3,960 miles. And 1 mile is 5,280 feet. By the way, and one estimate for that, an approximation would be 4,000 miles. One easy number to that, which is an easy number to remember, just in case. But it's actually 3,960. Again, on the equator. So if you notice the radius here and the radius here, right? That would be the radius of the Earth. This goes up by 362 feet, okay? And all we have to do, this arc length, S equals R theta, we want to find this distance because that's the distance that is supposed to be what they tell us, 26 miles, right? So if we look at this triangle, ABC, this is a 90-degree angle, okay, everybody? ABC. In order to find S, we need theta. In order to find theta, we are going to go with this triangle and say cosine theta is the adjacent over hypotenuse. Now, what is the adjacent to theta is the radius of the Earth. What is the hypotenuse? Is the radius of the Earth plus 362 feet, which has to be divided by this number to become a mile. So cosine theta, the adjacent is this number 3960, and the hypotenuse is 3960 plus this number divided by this number. Why are we dividing this? Because this is in feet, 362 feet, but this is in miles. That's why you divided, everybody. So pay attention as to why we divide by 52. You put it into a calculator, you get a, and this is what I mean by decimals. This is very close to 1, but if you use 1, okay, then theta, which is cosine inverse of 1, becomes 0, okay? And so, but you put this number and you get 0.33715 degrees, and now you're going to go with a lot of decimals, okay? That's why. Because again, this, if you assume it to be 1, this becomes 0. Now, S equals R theta. Okay. First of all, we're going to change this to a radian by multiplication by pi over 180, which becomes even smaller. Then we're going to multiply it by R, 3960. Becomes 23.3 miles. But they said 26 miles. Overstated the amount. A quick recap. So this is the radius of the Earth. This is the radius of the Earth. This lighthouse is above the sea level by 117 plus 245 equals 362 feet. And we want to see how far we can see it. So we can see it somewhere here. So we calculate the distance of S equals R theta. To calculate this distance of S equals R theta, we know the R, we need theta. To find the theta, we go with this triangle, and cosine will give us the value of theta. Find the angle of elevation of the sun if at 10 a.m. on April 26, 2000, a building 300 feet high cast a shadow of 50 feet long. So here's the sun. This building is 300 feet, and it creates this shadow of 50 feet. And so obviously we are interested for this angle A. Tan of A is the opposite over the adjacent, 300 over 50. So this is the angle we want, and 300 over 50 is 6. So A is tan inverse of 6. The calculator gives us 80.5 degrees. So again, the sun gives rise to this shadow. The shadow is 50, and the height of the building is 300. Tan A is 300 over 50. A laser beam is to be directed through a small hole in the center of a circle of radius 10 feet. So here's the circle of radius 10 feet. The origin of the beam is 35 feet from the circle, so the distance of 35 feet. At what angle of elevation should the beam be aimed to ensure that it goes through the hole? So we know it's 35 feet away from it, and we know this is a circle of radius 10 feet. So here's what's happening. We're going to call this theta. This is 10 feet, and we want to calculate this angle. Tan of theta is the opposite 10 over the adjacent 35. So theta is tan inverse of 10 over 35. By the way, everybody, we know we can simplify this. So tan inverse of 2 over 7 from the calculator, 15.9, almost 16 degrees. All right, finding the bearing of a ship. A ship leaves the port of Miami with a bearing of south, 80 degrees east. So right here, south, 80 degrees east. East is on the right side, right? So south, 80 degrees east. So that's the way it looks like. So this angle is 80 degrees. And a speed of 15 knots after 1 hour. So it goes for 1 hour. The ship turns 90 degrees towards the south. So towards the south. So this is 80 degrees and this is 90 degrees towards the south. After 2 hours, so it's going to go for 2 hours, maintaining the same speed. The speed was 15 knots. What is the bearing of the ship? From port. So we're going to connect those and we're going to call this B. We need to calculate this theta. When we find this, the bearing will be south, theta, east. So I hope everybody's clear what we are trying to do. South, theta, east. If this is 80 degrees, if we find this one and subtract it from 80 gives us theta. In other words, the find angle AMB, AMB. Okay, so let me see if I can show it. Yeah, right here, it shows it here. This one. We find this angle, subtract it from it. So theta, in essence, is AD minus angle AMB, and all you have to do is just find that with the information that you have. Now, what is this? You can go with the tangent of that, is the opposite AB over the adjacent AM. The angle has a tangent, opposite is AB over adjacent AM. So what is AB? What is AM? As you can see, AB, because this was over the course of 2 hours, so 2 times 15. Doesn't matter that it's 1.51 miles per hour. We're going to use the same unit. So 2 times 15 is the top. AM, this distance we went for 1 hour, 1 times 15. So 2 times 15, 1 times 15 becomes 2. And obviously, the angle would be tan inverse of 2. Putting it into a calculator results in 63.4 degrees. Subtracted from 80, gives us 16.6 degrees. So we say south, theta E, south, 16.6 degrees east. So a quick recap. We know this is 80 degrees because they said so. So we go for 1 hour, then we make a 90-degree angle. Let me just, and we go for 2 hours. And we want to find the new bearing. The new bearing is south theta east, and theta is 80 degrees minus the yellow angle. So you find the yellow angle and you're done. A camera is mounted on a tripod 4 feet high. So this is 4 feet. At a distance of 10 feet from George, who is 6 feet tall. Camera lens has angles of depression and elevation of 20 degrees. Each one is 20 degrees. Will George's feet and head be seen by the lens? If not, how far back with the camera need to be moved to include George's feet and head. The idea is that if you extend that, do we hit the foot, the feet, do we hit the head? And as you can see, this is 4 feet. So if you continue here and you get 4 feet, 4 feet at the bottom, 2 feet at the top. So first and foremost, let's say we don't know the distance and we call it X. Secondly, let's draw this triangle, okay? And this is 20 degrees, this is 20 degrees. So this is X, remember, not 10. We are going to figure out what it should be. And this distance we said is 4 feet, right? So from here to here is 4 feet. From here to here must be 6 minus 4 or 2. So this is 4, this is 2. And what is this distance? Not 10. We are assuming it's X. So that is understanding what's happening. Now, tan of 20 degrees is the opposite over the adjacent. 4 over X. And it's important to understand why we are concerned with this. Because if this covers the bottom, obviously it covers much higher here. So it covers somewhere here. So it covers that. But if it covers just the head, it can cover 2 feet down. But we need 4 feet. So we're going to go with 4, not with the 2. In other words, note, using 4 feet guarantees the foot is covered. Consequently, the head is covered 2, and even more since 4 is larger than 2. It's important to understand how that works. We can interchange those. X is 4 over tan 20. And if you put that into a calculator, divide 4 by tan of 20, becomes 1099. And 10 is not good enough. So we need almost 11 feet. No, the camera has to move back by almost a foot. That to take care of the business.